I wanted to just quickly go through the marking of A-level and AS and A-level exam scripts, and just to bring to your attention some of the things that you need to consider. So the general things are marks are obviously awarded for each part of an answer, and we're given information about how to mark, and we can use various ways of marking, M1, M2, M3. That'll tell you what you get in your mark for when you compare it to the mark scheme. So the mark scheme contains all the information that examiners would use to mark. So the first thing is, when you're looking at a mark scheme, things that are emboldened, so they'll be bold. So if it's a 2-mark answer, there might be 3 or 4 possible answers, and as long as you've got any 2 from a potential list, then you'll get those marks, those potential marks. So if it uses and in the question in the mark scheme, you've got to give 2 parts to it. So you can't just get 1 mark for 1 part of the answer. You'd need the other part as well. So sometimes you might think, I've got the answer, but it requires a second part to that answer. And alternatives. So this may be where you give an answer, but something else might be acceptable as well. So that's also shown in the mark scheme. And sometimes you do get other wording. So as it's shown there, it gives that in the mark scheme. Okay, and the other thing is marking lists, and quite a few people do tend to give more than the required number of answers. So marking a list, we have this thing called a list principle, the general list principle. So if you give a right answer and then you give a wrong answer, then the wrong answer negates the right answer, so it's wrong. So I'd give you 1 mark, but then I'd take 1 mark away. So in respects, you've lost the mark that you've gained. And so each error that you give negates however many marks that you've got, until you get to 0. And the other thing is that some remarks are considered neutral. So you might give a list, but actually I may be able to ignore some of those. So that can make it a little bit complicated, but I'd suggest to you that you don't have a list at all. So as it says here, sometimes there's an ignore. So if you give a list and it says ignore certain things, then I don't take that mark away. And this table here just shows you how the list principle works. So if these are the correct answers, or the marks for the correct answers, and you give that many correct answers, and then these are the incorrect answers that you give alongside it, then these are the marks that you're going to get. Okay, so you can have a look at that yourself. So what we can look at here, marking for calculations. So most of the time, if you give a correct answer, if you get the correct numerical answer, then you'll get full marks. Unless it says, show your working or justify. So here we can see if it states, show your working or justify your answer, then you're going to have to clearly show your working out. However, it's always good practice to show your working out, because what you can get are process marks and error carried forward marks. And that is stated here. So you may get process marks by showing your calculations. And I would always urge you to show your calculations regardless. And then taking errors carried forward, you may see on your scripts that you've got ECF, errors carried forward, and that might be because you've just made maybe you've made an error in transposing numbers. You may have done a slip on the calculator and then carried that forwards. Normally you only get penalised once for that, but if there's a couple of errors within your calculation, then it may be that you don't get error carried forward and you don't get the mark at all. When it comes to equations, looking at the exam mark scheme gives you an indication of what you can get, but most of the time state symbols are generally ignored. If you put state symbols in, we ignore them. If you don't put state symbols in, it doesn't matter unless it says state symbols are required. Then you will have to put them in. And also, this is quite useful. So when you're balancing equations, obviously you get credit for correct equations, but multiples and fractions are also acceptable. Oxidation states, they're always assumed to be positive, so I always encourage you to put a positive number in front of an oxidation number to show it's positive. Specifically, you have to show the negative oxidation state, so maybe -2 or -1, but it's always good practice to put positive and negative. And then my personal favourite, it. Sometimes it's not clear what it is referring to, so it's better to name it, and then there's no ambiguity. So you're taking a chance by using it or they. It's better to name what it and they are. Phonetic spelling, so usually spelling mistakes or the way that you spell things are not penalised unless it can be confused with something else. But things like adsorb, absorb, adsorption, absorption, they do need to be spelt correctly because they are so similar that it's possible that it's, again, ambiguous as to which you're meaning. So you do need to make sure that spellings of certain words are spot on. Brackets in the mark scheme means it's helpful to have it there, but it's not essential to gain the mark. So again, that's in the mark scheme, using the mark scheme. And this ignore, insufficient, do not allow. Looking at the mark scheme, it might tell you what you can ignore and carry on marking, or it might say do not allow. Do not allow means you're not allowed to give the mark. Or that's a wrong answer. So if you give that, it's a wrong answer. And it may mean that it might negate a correct mark that you've got, so you may not get the mark. And this is interesting, marking crossed out work. So if you've written something and crossed it out and then not attempted to replace that work with some other work, then I will mark it. It will get marked, and you'll gain marks if there's credit-worthy information within your crossed out work. Obviously, if I can't read it, I can't mark it. But if I can read it, then I will give credit if there's the possibility of giving credit. And reagents. So the command word identify. Okay, you have to. It allows you to choose to use either a name or a formula. But if you get the formula wrong, then you won't get the mark. So a wrong formula, or incorrect formula should I say, won't get you the mark. So if you're trying to write potassium dichromate and you write potassium dichromate like that, which is obviously incorrect, then that wouldn't be right and you wouldn't get the mark. So I would always suggest using the name. And again, it says in some circumstances the list principle might apply where the name and the formula are used. So if you're trying to use the name and the formula and you get the name right but the formula wrong, then you may have the mark negated because the formula's wrong. So my advice is to use the name rather than try and use a formula that you don't really know very well. And the other thing is this failure to identify reagents. So saying, for example, cyanide ion instead of potassium cyanide, you've not identified the reagent, you've just identified a reactive part of that, and that's on this other side here. So here, cyanide ion is not the reagent is potassium cyanide. Or if you say hydroxide ion, that's not the reagent is sodium hydroxide. Basically, what is it you're going to get off the shelf? What is it you're going to get out of the bottle? So you have to name the reagent properly. So as I say, I would use the name as opposed to the chemical formula unless you really know it. And also here, this is the ion that you've got in Tollens reagent or ammoniacal silver nitrate. That is the reagent, Tollens reagent or ammoniacal nitrate, silver nitrate. It's not this ion. So you wouldn't get credit for giving those ions, even though they are the reactive species within that. However, as it says here, if you use KCN and then say cyanide ion, so you could say it's the cyanide ion which you get in potassium cyanide, or potassium cyanide which contains the cyanide ion, then actually that's okay because you've named the reagent and this is not contradicting the reagent at all. The interesting part here now is the organic structures and what is and what are and what are not allowed. So you have to understand the specific types, and as it says here, the displayed formula shows all the bonds and all the atoms, but you don't need the correct bond angles, so that's the full displayed formula. The skeletal formula, you don't have the hydrogens on, you only show the carbon atoms at an angle, so that they appear at the angle that you draw. Any functional groups do have to be drawn in, as it says there. So secondary amines, aldehydes, N-substituted amides. Structures must not be ambiguous. So if you've got 1-bromopropane, then it should be shown as this is propane with the bromine on the end group. Okay, it's not the molecular formula, and quite a few of you are actually writing the molecular formula, so you have to write. I would recommend that you always write the structures out. Avoid these molecular formulas like the plague unless it says molecular formula. And then here, as it says here, bonds need to be drawn correctly between the atoms. Showing where the functional groups are attached to a carbon, like a nitrile group or a carboxylic acid. So a nitrile has the 3 double bonds between the carbon and the nitrogen. The aldehyde, CHO or CH double bond O. So you need to be able to show. And as it says, wrongly bonded atoms are penalised on every occasion. Every occasion. So I'll show you below. So the same principle does apply to alcohols. So if you do CHO, then that is penalised on every occasion. The alcohol should be COH. And C double bond C, it does say a little bit of latitude should be given around that. However, please don't have flying single bonds. They do need to attach, and I'll show you some information about that. CH3 is probably the only one that's interchangeable, and again I'll show you that on this next page. So again, it says similar latitude is given to amines. So NH2C, normally it's preferred to be H2NC because the N is connected to the carbon, the H's are connected to the nitrogen, so that's preferred. And these vertical bonds, it says, should not be penalised. For poor presentation of vertical bonds, they shouldn't be penalised. But they do have to look like they're attached. Okay, so it says the limit of tolerance is the halfway position between the vertical bond and the relative atoms, but they do need to look to be attached. So let's have a look at some examples. So the things that they've said about CH3, these are allowed, so these are the vertical bonds, so CH3, CH3, these are allowed. It does look like that H and C are connecting, but this is allowed as it's recognised that CH3 is the terminal group. However, this is not allowed. As you can see, the CH3 is here and this CH2 is at the end, so it looks like that's a pendant CH2, which is incorrect. Then it was talking about the OHs, so this looks like it's an O attached to a H, which is attached to a C, which is obviously incorrect, and that should be HO. And similarly here, this is this flying vertical bond, because it looks like the vertical bond is attached to the H. So that wouldn't be allowed, so the O needs to be attached to that vertical bond, and the H a pendant. I'll show it up here, so it should look like OH, so that the bond is attached to the O and then the H is attached onto that O instead. Again, what it said about the NH2s, it's allowed that this looks like it's attached to hydrogen, but again it's recognised that the NH2 is the end part. Similarly on this benzene ring, they're all allowed. However, when we're looking at nitro groups, you've probably not come across those yet. This looks like this benzene ring is attached to the oxygen, when actually it's attached to the nitrogen. So this should be written O2N and then attached to the benzene ring. There's no latitude really with the cyanide groups, because this is a C triple bond N. So this is what this should look like. This should be NC attached to the carbon ring. And similarly here, there's this flying vertical bond. This should be attached to the carbon and not attached to the nitrogen. Writing carboxylic acid functional groups, this is not allowed, because again it looks like the carbon's attached to the hydrogen, so this should be HOOC is the best way to write that. And again the same here, this should be COOH, so the bond is attached to the carbon and not attached to the hydrogen. Here you can see the same sort of thing. The carbon is attached to somewhere in between the oxygens, which is not allowed, so that should be attached to the carbon, COOH. And we can see with the aldehyde group, it looks like this carbon is attached to the oxygen, which is attached to a H and a C, so we should be writing here, this is OHC. In fact, I probably wouldn't write that. I'd probably put C double bond OH. This isn't allowed either, because again it looks like the oxygen's attached to the carbon, so this would be CHO. This looks like the carbon's attached to the hydrogen, so this needs to be carbon attached to carbon, CHO. These chlorides, acyl chlorides, oxychlorides, it looks like the carbon's attached to the chlorine, when in fact it isn't. The carbon is attached to the carbon, and we've got ClO, so that's ClOC. And same here, this should be COCl. So do be very, very careful when you're writing your structures, because it's very easy to get it wrong. So get into some good habits there. So some examples of structures. So this obviously is incorrect for an ethanol, because this looks like it's some sort of alcohol. So that should be CHO. That's how we represent that. Ethanol, having this HO is incorrect. It should be OH. And similarly, you can have a look down that group and you can see which structures are not really correct, but it does say some examples that should not gain credit. So these should not gain credit. Okay, so the following structures should gain credit as alternatives to expressions. So here you can see an ethene, CH2CH2. We could also have H2C double bond CH2, so that and this would gain credit. This is an alcohol in the centre, CH3CHOH, and as you can see, we can show it with brackets. Okay, so just going back to here, as you can see, it's saying some examples are given here of structures for specific compounds that should not gain credit. And so CH2CH2 for ethene, or CH2 dot, or CH2 double dot CH2. So these shouldn't gain credit, which we need to remember, because one of my failings is I sometimes write CH2CH2 for ethene. So we need to remember to put in the double bond in between. Okay, so as it says here, in most cases, using sticks to represent CH bonds are not penalised. The only time is when you miss them out and they're essential in a mechanism, or when it's asking you for a displayed formula, or if you use them in a skeletal formula when you shouldn't do. So again, be aware of the mark scheme. And then here you can see a list of organic names which should be marked incorrect. So using any of these which are not correct, these should be the alternatives. So just to point a few out, the first one, but-2-ol, it should be butan-2-ol. 2-hydroxybutane, which was the old name for butan-2-ol, so you should be using butan-2-ol. Butane-2-ol, putting the E in, so it should be butan. And 2-butanol, because it's not obvious where the ol is, it should be butanol. So again, just have a look through these and see what you should be using. See the typical errors that people make and make sure you avoid them. And then we come along to the organic mechanisms, my favourite. So it's really about getting your curly arrows correct. And as it says here, the curly arrows originate from a lone pair of electrons or from a bond. Okay, and the following representations, as it shows here, won't gain credit. So, for instance, this arrow isn't going from a bond, it should be going from here. We can see that we've got a line and electrons, so that's incorrect. So we shouldn't have a line and electrons. And similarly here we've got a line and electrons, and we're showing this as some radical braking mechanism, but that's incorrect. So this would suggest you've got a pair of electrons and a pair of electrons, so two pairs of electrons, and this is showing a pair of electrons and two electrons, again, which is incorrect. This one looks fairly correct, however this arrow isn't going from a pair of electrons, so it needs to go from the pair of electrons. And similarly here, this is only showing the charge, so it's not the charge that is moving, it's the pair of electrons that is moving. And in this following mechanism, it's obviously very wrong, because we should be going from the pair of electrons, and it should be these electrons which are moving. So we do have to be very, very specific with the use of curly arrows. So this is a habit well worth getting into. And looking at radical substitution mechanisms, so the absence of a radical dot should only be penalised once within a clip is an answer, so within one answer. We don't actually use radical half-headed arrows for radical mechanisms. That's not something we do in our syllabus, although incorrect use of the arrows will be penalised if you decide to use them, but I haven't taught you how to do that, and we're not required to do it. So here it says using a skeletal formula in a mechanism is acceptable, and it's acceptable to put a CH bond in if the CH bond is what's breaking. So it must be shown in order to gain credit. So we do need to look at where those bonds are broken. Okay, so extended response questions. These are usually the 6 markers, although 4 and 5 markers can be referred to as extended response unless they're calculations. And what we do with those is read them through. These are typically the explain questions, describe and explain, and you have to put a lot of words and facts in there. So what we tend to do is we read through it and get some sort of holistic view. We start at the lowest level of the mark scheme and see what we can give and see where it meets the descriptors. So when assigning a level, we do tend to read through those answers and sort of think, is that going to be a level 1, a level 2 or a level 3? And it has to meet the descriptors within the level 1, 2 and 3. You don't have to get like 6 facts to be able to get all 6 marks, but you do have to score within each of the stages and following the descriptor. So if it's a level, say a level 2 answer, then looking at the descriptor, is it a bottom part of level 2 or a top part of level 2? And you'd be awarded 3 or 4 marks depending on how complete within that stage it is. So these extended response questions are well worth you reading the examiner's reports and looking at the mark schemes to get the full marks. As it says here, for other extended response answers, we can look at the mark scheme and we can look at the direction we're given. So looking at linking words, therefore, so, because, they're optional to use. So if you can't sustain a reasonable level of logic, if you haven't got a flow to your answer, then you may be limiting yourself to what you can get. You may be limiting yourself to just level 2. But if you've got a logical flow, it follows in an order and it's not darting around, then you have a more chance of getting into a level 3 and getting 5 and 6 marks. So the mark scheme and the guidance is well worth you looking at, having a copy of and referring to when you come to do questions.